Enlargements. To do an enlargement, or it can be a reduction. If it's a reduction, then it will have a different number for the scale factor. So if we've got a scale factor of 2, that means we're dealing with an enlargement because we're doubling everything. If we had a scale factor of 1/2, then that would be a reduction, making the shape smaller. So along with the scale factor, what we also need to know is the center of the enlargement. So we need the coordinates of that point. So let's have a look at an example. So here's our first one. So we've got a little L shape down here, and they've marked on already for us where the center of this enlargement is. I'll just blob on there a bit more. Okay, so we've got to enlarge this shape by a scale factor of 4. So that means this will be 4 times that, 4 times this as well. Okay, but the important thing is that we've got to get it in the right position. So the easy bit is making the shape 4 times bigger, but we've also got to get it in the right position. So the way we do this as well is that these points, these corners, have to be not 4 times as far away from the point as they are when they start. So this point here, for example, is only 1 away. So in our enlarged shape, it's going to be 4 away. 1, 2, 3, 4. Okay, this point here is 3 away. So in our enlarged shape, it's going to be 12 away from here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, like so. And because this is a relatively simple shape, now we've got that in, it should be quite straightforward to draw the rest of the shape in. So we've already got the enlarged part of the bottom here. So it's 2 high. So 4 times 2 will be 8. So we need to go up 8. So that's 2, 4, 6, 8. So it's 8 this way. Yeah. And then it's across 1 here. So that means it will go across 4, down 1. So that's going to go down 4 like that. So I'm just going to blob those in so we can see where all those points are. So now we can finish drawing that shape. Okay, but the crucial initial step was understanding that not only do the sides of the shape get 4 times bigger, but it moves 4 times away from the center of enlargement that we have here as well. So it's 4 times away here. And if you were to measure it, even if you did that and then did 4 times, you would end up there. It literally does work that way. So next example. So this time we've got a rectangle there. We've got to enlarge it by a scale factor of 2 using the center of enlargement -1, 0. So let's find where that one is. So where is x -1? Here, and 0 for the y. So that's our center of enlargement there. Okay, so might look a little bit more challenging, obviously, because we're in the middle of it in there, but just think about it carefully. It's going to be fine. Okay, so every point is going to be twice as far away as it was when it started, as well as being twice as long. So if we think about this point right here, it's 1 away now, so it's going to be 2 away when we've finished. And this point here is 2 away, so it's going to be 4 away when we finish. Now let's see if that makes sense. So this is 3 squares high. We know that we want to make that therefore 6 when we do this. So let's look. We've got 1, 2, 3, 4, 5, 6. So that's right there. So again, if we do the same sort of thing coming this way, that's 1 away. So it'll be 2 away on this side. And on this side, it's 1, 2, 3 away. So it's going to be 6 away. So another 3 is going to take us to there. And this is 1, 2, 3, 4 wide, so we expect it to be 8 when we finish. So it's 1, 2, 3, 4, 5, 6, 7, 8. So we can see there. So although those weren't corners, we could still play the game, so to speak, of moving it away the same distance. So if we now just draw in those 4 lines, we'll be able to see our final enlarged shape. So just a little bit more thought needed there because the point was inside the original shape, but still doable. So it's really important to understand, yes, the sides get twice bigger in this case, but it's also about them moving 2 times as far away from the point of origin. So one last one. So this time we've got a little triangle here, and here's our point, and again it's a scale factor of 2. So remember, we're going to make sure that they move 2 away. Now this one's slightly more challenging because it's more diagonal from where we're starting. But if we just think about this, so we're going to move point B to start with. So point B is 1 down and 2 across. So if we double that, it will be 2 down and 4 across. So that means that B will be there. Whereas A here is 1 down and 4 across. So when we move that, it's now going to be 2 down and 8 across. So 2, 4, 6, 8. So this is 2 wide. We're expecting it to double 1, 2, 3, 4. Okay, let me draw that line in now. Okay, so all we need now is to move that 3rd point so that we can finish this off. So at the moment, this point here is 1, 2, 3 down and 1, 2, 3 across. So it now needs to be 6 down and 6 across. So it's going to go there. And now we've got that point, we can just join up our dots to get our triangle there. Okay, so let's now have a look at figuring out how to describe an enlargement. So it says describe fully the single transformation that maps shape A onto shape B. So it is actually an enlargement. We're doing it that way around. So the first thing we need to say is that it's an enlargement. The next thing we need to tell them is the scale factor. So pick one of the simple sides. So I'm going to pick this one here. So it's 2 wide on the A and it's 1, 2, 3, 4 wide on the B. So that's twice as big. So it's a scale factor of 2. So now what we've got to do is figure out where that origin is. Where was the center? Okay. So the easiest way to do this, you can do the sort of counting stuff that we've talked about before, but backwards, okay? But the easiest way to do this is actually to draw some lines on here and work out where they cross. Now these lines need to go through, so I'm going to pick this point on the big shape and the same corresponding point on here, and I'm going to line that ruler up to those points, and I'm going to draw a line through it. Now obviously with a pencil this is a bit more precise and easier to do, but just draw it all the way through. Now I'm going to do the same for all the other points. So this point with this point now. Okay, so we line those up best I can with my chunky pen here. Now I'm going to do the same with the others, so this one and this one. And then finally these two in here. So we line up You want to do it as close and accurately as you can do. Okay, I think you get the gist of what you can see here. This is the point where all of those lines cross, so that is the center of enlargement. So we just need to write down the coordinates of that point, which is 7 here, and this way is 6. So our coordinates for our center of enlargement is 7, 6. Okay, let's have a go at one more. So again, we're describing it. So the first thing we're writing down is that it's an, well, this time I'd call it a reduction. I've just read what it said here. It says A onto B. So we're going from the big to the small. So it's actually a reduction. So now we need to look at the scale factor. So again, just pick the easiest bits to look at. So it starts off as being 2 and it becomes 1. So it's a scale factor of a half. We've halved the measurements. So once again, now we need to find that coordinate. So we're going to go and draw our lines through all those points again. So just make sure you're doing the same point on both shapes, okay? So let's do those two first of all. Always draw it right across the graph because you don't know where they're going to cross. So just do them nice and long. Okay, so now I'm going to do these two here. And now I'm going to do the points here as well. You can begin to see where it's most likely to be, but let's keep going and do all of them just to be sure. So I'm going to do these two here now. Okay, it's much easier when you're using a pencil and not a felt tip, as you can imagine. Right, and then finally these here. Okay, so if I just remove the ruler there, you can see that they meet up here. So the coordinates of these are 1 and 5. So the center of enlargement is 1, 5. So that's how you describe an enlargement or a reduction.